Windows machine, I want to do this F210. So first, you download this memory dump, which is, I think, from an old machine I made, Windows XP, I think. Had it around for years. And it's a 7-zip file, so you need the 7-zip extractor, which you can install on your Windows. If you haven't already, you get it from 7-zip.org. So here's the memdump file. You right-click, and then you got to go to More Options, because Windows 11 likes to waste your time. And then you find a 7-zip option, and now you can extract here. And so now it's going to unzip that file. All right, and now I have a file called memdump. Let's sort by name. It's still determined to group them by date. If I can find some way to turn this garbage off, I would sure like to. That Microsoft always has to find a new way to irritate me. It won't put the files in alphabetical order anymore, so I can't find them, and I don't know how to turn off this grouping. They keep inventing some new stupid feature and make it hard to turn off. Anyway, somewhere in this mess is memdump. If I type mem, it should go to it. There it is, memdump.mem. So notice the memdump.mem is 500 kilobytes, half a meg. No, 500 megs, half a gig. That's what I thought. So this was on an old Windows XP machine with half of 1 gig of memory, which was enough back then. So we want to analyze that. This used to be quite a chore, but now it's all built into Autopsy. So after you've got it, we wanted to verify the hash, and this helps me. Students point out hash calc is gone. You can't download it anymore, but you don't need it. You can use PowerShell. So here, the MD5 should start with B50. So let's get the MD5 hash of that thing. You go to PowerShell, and then move into the folder where it lives, which is downloads, and then dir mem star.star. Show that my memdump is there. So now I do get-file hash -algorithm MD5 of memdump.mem. There we go. That's why you don't need hash calc anymore. You can do it right here. So the hash starts with B50A, and I think that's right. Yep, B50A. All right, so the file is intact. You always want to do that to make sure you got a good download. Now we go into Autopsy, and we have to go into experimental plugins and activate memory analysis. So let me get down here and launch Autopsy. All right. And I probably will have to do this. This is a brand new machine, so I don't have previous semester's settings in my Autopsy. So that's better for the demonstration anyway. So it's Tools, Plugins, Installed. All right, here's Autopsy. And Tools. I guess maybe I have to make the case first. Let's see. Launch Autopsy. Oh, nope, I can close the open box, all right? So I'll close this. There we are. Now I can do Tools, Plugins, all right, and Tools, Plugins, Installed, Experimental, Installed, and Experimental, there it is. Experimental, and then I think it's Activate. Activate, finish, okay. Activate the experimental stuff, and activate. All right. All right, and finish. So theoretically that will, didn't get checked though. It's a little disturbing. Available plugins, installed. There, now I see a checkbox there. Now I feel better. I'll close. All right, theoretically it's there. Let's see if it works. So once you've got it, then make a case, memory, and it is a memory image file. All right, let's see if this works. So make a new case. Okay, memory, next, mem, finish. All right, well, that's going. I'm going to check the instructions. See, import the memory image. Now, how do I tell which module? I can speed up the process. That's what I thought. Okay, so yes. Okay, it's doing something. Here we go. All right, so I don't care about the host name, but it is a memory image. There we are. Volatility is the command line tool I used to use, and it's going to automatically run volatility for us. Okay, there we are. Now I can browse for memory image file, which is in my downloads folder. Don't know why I'm not able to find it. There it is, downloads. And in there is mem, dump.mem. There we go. All right. And now you can just leave them all checked, but if you want to speed it up, I made a list of things to check. Consoles, hash dump, LSA dump. So I wonder if I can do this with the, oh good, I can use the space bar, good. Consoles, hash dump, LSA, okay, so I can dump everything down to hash. There's hash dump, those are password hashes, okay. And then LSA and net. Probably zoom in to make this easier to see. All right, there's LSA secrets, I want them. And then I want net, PS list, and shell bags, okay. Net. And PS list, okay. And shell bags. And user assist, I think. Yeah, all right. Those are just the ones I found that gave me useful information on this data. Okay, so only those ones are selected, and now I do next. And in the next window, I would think I can uncheck everything. Let's see. Configure, I just say do next. All right, guess I'll just leave this alone and do next. All right, so it's running image info. This is, I remember doing this manually. First you use the image info command to identify the exact version of Windows that was used. Then you refer to that in the later commands to extract each of these things. And each one of those boxes is going to be a separate run of the tool, which I think is volatility. There's a couple of memory scan tools, and each one takes a while, scanning through the whole image to find matching information. So it's going to take a while, but I'm just going to go to the instructions to point out what it's going to find when it works here. All right, so when you're done, you'll find a bunch of things. In the consoles, you're going to find the command line that was executed. So here is the C users administrator, and the net user command was used to create some users here. And when you create a user, you can specify the password right there. So you can find somebody's password by just seeing what was typed in the consoles. That's in memory. The password hashes are in hash dump. This is what Windows password hashes look like. There's a name of the user, an identifying number, and then there's a meaningless hash that is always the same because that's the old LM hashes that are no longer used. And then comes the NT hash, which is Microsoft's more secure system, only 1,000,000 times less secure than the Mac or Linux. And that hash for the Waldo account is the one to is the flag. Then there's LSA Secrets. This is something under circumstances stores plaintext passwords in Windows systems. It's one of the disturbing security flaws in XP. I think it's somewhat better in modern versions. You'll find the administrator password just sitting there unencrypted. And NetScan shows a list of what listening ports are open. So you'll see various ports you're listening and identify what process is listening on port 8080 here. Like I say, there's all the stuff you find in memory, all the running processes. And here's PS list. There's a list of all the running processes. So again, you can see this thing was running Notepad and Adobe ARM and so on. Internet Explorer, another Notepad, and another one there. So you can find all the running processes. And shellbags will show you the name of the shared folder it was connected to on a server. Shared folders and then the name of here. So it was, that's the kind of stuff you find in here. And then User Assist. User Assist shows you in executables that have run recently, and there's one here that's obviously malicious looking. You'll find it. Even more malicious than evil2.exe. So anyway, and then you can find the password for the probe account. If you go back to here, to look at the password hashes, there. See, there is a probe account, and there's the hash, so you can crack that hash. There are online tools to do it, and there are offline tools. So if you're interested for extra credit, you can crack that hash and find out what it is. E19CC. All right. So that's all I wanted to show you about that project. Let me stop the recording.